And you must know valence electrons, electronegativity, Lewis dot symbols, and chemical bonding. If you don't know these, then go back and look at some of the previous lessons and get to know, especially Lewis dot symbols and electronegativity. Oh, here we go. Here's some review. Valence electrons are the electrons in the highest energy level, and usually the S and Ps. Electronegativity is the measure of an atom's ability to attract electrons to itself, and increases as you go across and as you go up. And that excludes the noble gases, though. Remember, noble gases do not have electronegativity. They do not want to give up electrons, and they do not want to gain electrons. Lewis dot symbols, a symbolic representation of the valence electrons. And here's sulfur's representation. There we go. Very cool. Remember, molecule refers to covalent compounds, a nonmetal to a nonmetal. A covalent compound is the sharing of two electrons. Oh, there's hydrogen and chlorine, sharing some electrons and creating a bond. Molecular geometry is the 3D shape of the molecule based on the bonds or electron pairs. 6 basic shapes. We have linear, angular, trigonal pyramidal caused by an unbonded pair of electrons, trigonal planar, tetrahedral, and trigonal bipyramidal. And you can get a handout of these. Just send me an email to Mr. Causey at mrcausey.com and I'll shoot off this handout to you if you don't have it. I think it might be on the website too, so you might check. Some of the advanced shapes. You have octahedral, square planar, square pyramidal, seesaw, and T-shaped. 2 theories involved here. We have the valence shell electron pair repulsion, and we have the valence bond theory. And the one we're going to focus on is the VSPR, or the VSEPR, the valence shell electron pair repulsion theory. And the VSEPR theory states the shape of a molecule is determined by the repulsion of the bonds and electron pairs. This shape is most stable when the electron-dense regions are as far apart as possible. Remember, bonds and lone pairs are both made of electrons. And that means they're both negative regions. Electronic shape. The arrangement of the electron-dense regions around the central atom. So when we're talking about this kind of situation, we're talking about electron pairs and bonds. Not just the bonds, but the electron pairs also. And there could be 2, 3, or just one lone pair of electrons. But they affect the shape of the molecule. Electronic shape of ammonia. And see how that looks there? This is tetrahedral, because we include the electron pair as well. The molecular shape, the arrangement of the atoms around the central atom, bonds only. Ammonia has a molecular shape of trigonal pyramidal. Now you need to look at that. Go back and look at the other one if you need to. When we're looking at electronic shapes, it includes the bonds and the electron pairs. But when we're looking at the molecular shape, all we're interested in is how the atoms and the bonds are arranged around the central atom. So this is a trigonal pyramidal, and we ignore the electron pair in the molecular shape. And the best way to get used to these is to practice. Let's look at an example of CH4, or methane. Okay, its electronic shape is what? Take a guess there. And the electronic shape is tetrahedral. Look at all those. No lone pairs or unpaired or unbonded electrons, are there? Molecular shape? Take a guess. Take a guess. Tetrahedral. That's right. This is symmetrical. And whenever you have a symmetrical shape like this where there are no lone pairs or unbonded pairs, your molecular shape and your electronic shape are the same thing. Let's look at another example. Water. Notice I always draw the structure first. I draw the molecule. Okay. The electronic shape, of course, is tetrahedral. It has 4 electronic regions, bonds and electrons. But molecular shape, if you cancel out looking at those unbonded electrons, get angular.